Okay, so we're going to be doing problem 2 for a video for problem 2. Problem 2 states, what is the magnitude of the electric field at point P when you have these source charges down here? So you have a -6 source charge and a +8 source charge. All the source charges are on an equilateral triangle at 3 centimeters. An equilateral triangle means all of the angles are going to be 60 degrees. So for our point charge here, we know we're going to have from the positive, we're going to have an electric field going away from the positive, so it's going to go up. And then for the negative, we're going to have an electric field that goes towards the negative. So it's going to go down towards the negative. And then we can make our little axis here. We know that this angle right here is going to be 60 degrees. And this angle right here is going to be 60 degrees. So we have two 60-degree angles. From there, we can use our equation. The electric field is equal to Ke times the charge over the radius squared. We can break this up into its components, its angular components. We did the +8 charge first, and for the x and the y. So you see, Ke times q over r squared equals the cosine of 60 for the y and the sine of 60 for the x. So we put all our numbers in. You end up with 39960 nanocoulombs for your x direction. So right here. And then 69200 in the y direction. We do the same thing for the -6 nanocoulombs, and we still use the sine and cosine of 60 to make the math easy. We use the sine and cosine 60, knowing when we get to our actual vectors, knowing the directions of our magnitudes, we put the negative signs into the vectors themselves in our vector math. So we got 29970 nanocoulombs and 5190 nanocoulombs, knowing that this first one's negative and these two both are negative because it's going into the negative quadrant 3, and this one, the x is negative and the y is going to be positive. And next we'll have the vector math.
Alright, for the vector math, what we're doing here is we're going to take our two vectors that we found. So for the 8 nanocoulombs, we found that it was -39960 I hat plus 69200 j hat. And then for our 6 nanocoulomb, we found that it was -29970 I hat, -51900 j hat. Once you add those up, your total electric field is going to be -69930 I hat plus 17300 j hat. Take the square root of those, and then we take the tan inverse. Once we do that, our total is 7.21 times 10 to the 4th at a 13.9 degree above the x-axis. Negative x-axis, sorry.
So now we're looking at the second point of the problem. So we have our electric field force, which is from both of these, and now we're looking if we put a negative 4 nanocoulomb charge there, what's going to happen and what's the force going to be. So if we look at our equation, force is equal to the charge times the electric field. We see that the charge is negative, so it's going to be going down at the same angle, 13.9, as the electric field was going up. So then we plug in our numbers, so -4 plugged in for Q, and then our magnitude from over there, which is 72,100 nanocoulombs. And then we get our final result of 2.88 times 10 to the -4th newtons.